lesson is lesson 4.5, compound inequality. This is the homework that goes along with it. This is another lesson that is in the 7th grade curriculum, and I would explain that in class. All right. Today's lesson is compound inequality. Okay? Compound inequalities are two inequalities that are joined by the word and or the word or. This is in the little note packet that I gave you. For example, okay, this one right here is red. X is greater than 2. Look at how I'm reading this backwards. X is greater than 2 and X is less than 4. This is read just like it says. X is less than -2 or X is greater than 3. An and statement, an or statement. Both what we call compound inequalities. This one, both parts have to be true. This one or the other has to be true. Because it doesn't make sense. A number can't be less than -2 and greater than 3. It's impossible. It's going to be less than -2 or greater than 3. This one, it has to basically be between 2 and 4. Well, 2.1, 3.9. It doesn't have to be a whole number. All right, review. That's less than or equal to, greater than or equal to. Right? Fill those in. And the circles on less than and greater than are open. Less than or equal to, greater than or equal to, close. We did this earlier this year, but we only had one answer. Now we're going to have a combined inequality, and it is no more difficult than what we already know what to do. So today's lesson, I think, is actually a pretty easy lesson. Okay. Write a compound inequality that represents each situation. Then graph all the solutions. All real numbers that are at least -4. Does that mean greater than or equal to -4? And at most 5. So X, at least 4, greater than or equal to -4, and at most less than or equal to 5. Write it that way. Now, when you are graphing this, I'm going to have a closed circle on -4, a closed circle on -5, because they are both equal to. And where does the shading go? In between. Right there is where all the numbers are at most or at least -4. The least is -4 and the most is 5. So basically between -5 and 4, I'm sorry, -4 and 5, including -4 and 5. All real numbers that are less than 8, X is less than 8, but greater than 3. So, or X is greater than 3. That's an or statement because it's not possible to be, oh yeah, I'm sorry. Yep, I thought that was a -8. Are less than 8, but greater than 3. So X is greater than 3 and less than 8. Always start smallest number, work your way up, X goes in the middle. Now, Open circle on 3 and 8 and shade in between. Number 3, all real numbers that are less than -6. So x is less than -6 or x is greater than 2. So put an open circle on -6 and an open circle on 2. Less than -6. I'm shading to the left and I need to put an arrow on it because it doesn't end. It keeps going. Or greater than 2. I will tell you a general rule of thumb. And statements are in between or statements go out. Now, there are always exceptions to that, and we may run across some of them while we're doing our lesson. Okay. Is this going to be an and or an or? Or. So, x is what to -3? Less than -3. Or, what is this? Can't even read that number. This is a 1. Okay? So, what will this part be? These numbers are hard to read. This is -1. Is this an and or an or? And. So x is greater than or equal to -1 and less than or equal to 4. Always start the smallest number, your variable, up to your highest. Now, here we go to the solving. Let's remember, when we are solving inequalities, if you multiply or divide both sides by a negative, you need to switch your inequality. When you have an or statement, it's just 2 separate little problems. So, add 2 to both sides. So, x is less than or equal to -4. Or, subtract 5, x is greater than 2. So, graph this. You know what I'm going to do? I'm just going to write -4 and 2. I don't care. I'm not going to count those out. Who cares? X is less than or equal to -4, or x is greater than 2. Same thing now, I'm not even going to bother doing that one. Too easy. Aha! Now, when you are solving a compound inequality that is an and statement, you are going to solve this just like any other inequality, except you've got 1, 2, 3 parts. You want to get x alone. So pretend that this was on its own. What number do I need to get rid of first? What do I need to undo first, Nick? Well, this is dividing by 2. So what's the opposite of dividing by 2? But I have to multiply all 3 sections. So times 2, times 2, times 2. Make sure you get all 3 parts. So this is going to be -6. Do I switch my inequalities? No, because I multiplied by a positive. So it remains less than. This will just be 3 plus x, and that's 14. How do I finish solving this? What do I need to do, Kimmy? Well, look, here's my x. I want to get x alone. Subtract 3 from all 3 parts. You are getting x alone. So, -6 minus 3 is -9. Do I switch my inequality? No, because I didn't multiply or divide by a negative. X, and then I've got 11. There we go. So, I'm going to jump over here. -9, or why am I writing 4? -9 to 11. And I could care less. Just put negative and a 9 and 11 on your graph. Open circles on both. Where's the shading going to go? Right, in here. We want the numbers that are greater than -9 and less than 11. So they're in here. Yes. Three plus x over 2 times 2 over 1. 2 goes into 2 once, 2 goes into 2 once. Right? That eliminates that 2. All right. Let's do this one. Let's solve this compound inequality. What am I going to do first? We want to get y alone in the middle. Nick? Subtract 2 from all 3 spots. So I'm going to have 3 is less than negative 3y, and that's less than 12. Now what am I going to do? Divide every single thing by negative 3. What happens to my inequalities? Now, look what happened here. Isn't my smaller number over here on my left? So I'm going to transpose this entire thing. Negative 4, look, pointy side towards negative 4, y in the middle, pointy side towards y, negative 1. So my answer is B. When you are writing an and statement, always start with a smaller number and use less than. That's just the way to do it. But always, leave a tip between 8% and 20% per server when he pays for his dinner. This can be represented by the system of inequality shown below, where y is the amount of tip and x is the cost of the dinner. Okay, look. So, his tip, y, is going to be greater than 8% of the dinner, and y is less than 20% of the dinner. So it's going to be between 8 and 20. Could I write it like this? Is that the same thing? Right? Our tip is somewhere between 8 and 20%, which is what this means. Same thing here, look. The big side is towards y, and the little side is towards y. Smallest down towards, or up towards. Which of the following is a true statement? When the dinner X is $10, the amount must be between 2 and 8. Well, if I do 0.08 times 10, isn't that 80 cents? Ouch. The cost of the dinner is 15. 0.08 times 15. What do you get? You get $1.20. And if you do 0.2 times 15, you get 3. So it's between 120. Make sense? All right.